Okay, so this review is all about trig graphs, and so we're going to start by looking at sine and cosine graphs. Generally, all of the rules that that apply to sine and cosine graphs apply to them both in the same way. The main difference is kind of what the graph starts out looking like. So if you look at sine, we have that same wave as we do with cosine. It's just that the main difference is that it kind of, if we think about where it starts on the y-axis, it's starting at the origin, going up, returning to the x-axis, going down, returning to the x-axis. So this is kind of like the snippet that we think about. And then for cosine, it is not starting at the origin. It's starting at the very maximum of its graph, and it's coming down through the x-axis to the minimum of the graph, and then returning past the x-axis back to the max. So the kind of main difference is sine is kind of starting at the middle of the graph, whereas cosine is at the max. Now, again, all of this talk of starting is relative because really that's just talking about where it is on the y-axis, but we can shift this whole graph around. So that's kind of the one section of the graph that we focus on. Okay, so the main idea is this A that's on the outside. That's talking about your vertical stretch or compress, so that's affecting the amplitude, which is kind of the half the total distance from the top to the bottom. And so the other thing that's affecting is that if that A value is negative, there's going to be a vertical reflection. So a graph that originally starts out looking like this, if it's reflected vertically, is going to look like this. It's going to go down first instead of up. And a cosine graph that originally starts out looking like this, if it has a vertical reflection, is going to then start at the bottom, go up, and then return to the bottom. So that's kind of the idea about the vertical reflection. Now, both sine and cosine have kind of an original period of 2 pi, meaning the length of this section of the graph is 2 pi. But it can be changed by this b value that's being multiplied by the x. And whatever that b value is, if we do 2 pi over the b, that will give us our period of the graph. And if we want to go the reverse direction, if we know the period and want to find out the b, we can do 2 pi over the period to get the b value. C, that's our horizontal shift. If we have x minus pi, that's going to shift to the right. If you have x plus pi, that's going to shift to the left. And so basically that just means the whole exact graph is moved left or right. And then the d value, that is shifting the whole graph up or the whole graph down. Now, looking at tangent graphs, a lot of the same ideas apply, but the main graph is not the wave that we're used to looking at because tangent doesn't exist at pi over 2 or negative pi over 2 or any of the coterminal angles in its original form. The reason is it's sine over cosine, y over x. And at those spots, sine is a value, but cosine is 0. So you're dividing by 0. So that's how we end up with asymptotes in our graph. And so then this shape kind of repeats itself over and over and over again. Okay. The asymptotes start out at pi over 2 and negative pi over 2. But if we change the period of our graph and we kind of spread this out, those asymptotes could be wider or more narrow. And if we have a horizontal shift, they could both just move over to the right or over to the left. So those asymptotes could change. Just like before, we kind of think about this A as amplitude, and we've talked about this in class. There really is no amplitude of this tangent function because it goes all the way to the top and all the way to the bottom. It's the same idea as the amplitude, but really we should call it a vertical stretch or compress. And so the idea there is that if you imagine pulling, stretching it out, it would make it kind of less curvy, or compressing it, pulling it in would kind of make it real exaggerated in its curve. The x minus c, again, shifts it to the right, or plus c shifts it to the left, and the d does shift it up and down. The period of a tangent graph originates at pi. So typically it's pi, but again, this b value can change the period. So pi over b will give you your new period. Or if you know the period, pi over the period would give you your b value. Okay, so the easiest way to kind of gain some understanding of this is to look at some problems. So it gives us kind of the generic form of this cosine graph, and it gives us the graph, and it tells us that there's this minimum at 0, -3, and this maximum at 4, 7. And so we're going to go ahead and assume that this whole graph is in radians because they didn't say degrees. There's no degree symbols, so we're assuming radians. And it asks us to find P, Q, and R. So the easiest two to find are generally P and R. So P is our amplitude, so that's half the total distance from the top to the bottom. So if the bottom is at -3, the top is at 7, the total distance there is 10. And so your amplitude is half of that, so that's 5. Now, we do have to check and see, is there a vertical reflection? So typically a cosine graph starts at the top, comes down, returns to the top. But as we notice, this one starts at the bottom, so that means there was a vertical reflection. So our A value, or in this case P value, has to be negative. So -5. Okay, the next one I'm going to look at is R. And so R is kind of the middle. And so typically a cosine graph starts at the top, goes all the way to the bottom, returns to the top, and the middle is on the x-axis. But we can see right here what looks like the middle is not on that x-axis. So there's got to be a vertical shift here, shifting it up. To figure out how much, we're just going to figure out the middle between -3 and 7. So 7 minus 3 is 4. Half of that is 2. So we can kind of figure out that 2 is the middle, because 2 to -3 is a distance of 5. 2 to 7 is a distance of 5. So the middle is at 2. So that's our vertical shift. The last thing we're going to figure out is Q, and Q comes from the period. So this is a cosine graph, so the B value, which is in this case our Q, is going to be 2 pi over the period. And so we have to figure out what the period is. So we know that a full cycle would be this right here, all the way up and then all the way down. We know the distance from here to here because it goes from 0 to 4. So that's got to be half of our total period. So that's 0 to 4, that's half, and then another 4 would complete it. So total, our period is 8. So 2 pi over 8 is going to be our Q value, which is, that is pi over 4. Okay. And then the last problem, we see this kind of thrown in various places in our IB problems. It says the equation y equals k has exactly 2 solutions. Y equals k, that's a horizontal line. So we're talking about where would a horizontal line on this graph only intersect it twice. And so as I'm doing this, you can see there's lots of spots here, 1, 2, 3, that intersects it 3 times. Here it's intersecting at 1, 2, 3, 4, 5. So it's not until we come down here that it would only intersect this graph 2 times. And so what is the y value when that happens? The y value is -3. Okay, so let's go ahead and look at a tangent problem. So they give us the equation right here, y equals 1 plus tangent of x over 2. And they give us the graph, actually, and they want us to draw in the asymptotes. So this is kind of a gimme problem because we can definitely see where those asymptotes are. Okay, and so we can draw those in. Then it says write down the period of the function. So if I were to, first of all, rewrite this function as 1 plus tangent of 1/2 x, just so that we have that divided by 2 as a coefficient. We could say that our b in this example is 1/2, and we know that the period is pi over b because this is a tangent function. So our period is going to be pi over b. Our b is 1/2, so pi over 1/2. So that gives us our period of 2 pi. Then it asks us for the value when we're talking about x being 90 degrees. We have a couple of different options for this. We could plug it in. Most people are tempted to say f of 90 and to go through the work tangent of 90 over 2 and go through the work of solving it algebraically. But another easy way to do that is to say, okay, 90 degrees is right here. What is it when f is 90? Well, here it is. What is the output there? That's got to be, if I drawn that correctly, that's got to be 1. Or I'm sorry, 2, because that's 2, 4, 5. So the value is 2. You could also have done this 1 plus tangent of 45. We know tangent of 45 is 1, so that's 1 plus 1, and we get the same 2 that we got before. All right. The last section says solve f of x equals 0 for negative 360 to 360. Again, we could do this algebraically and set 0 equal to 1 plus tangent of x over 2 and subtract and do all the work of solving it. But again, it's going to be easier to just look at the graph. When is y equal to 0? Well, that's right here, and that's right here. So let's see, that's at negative 90. And that looks like halfway between 360 and 180. So that's at 270. And those are the only places, since it's a graph from negative 360 to 360, those are the only two places. And so it's a lot easier to just look at your graph for that. Okay, so for our last problem, it tells us that part of the graph y equals p plus q cosine of x is shown. And it does tell us that the graph passes through 0, 3, and pi negative 1. So we can go ahead and label that 0, 3, and that's got to be pi negative 1. Okay. And so one thing I might do is just kind of rewrite this in a form that you might notice would look more similar to what we've seen, kind of like that. You don't have to, but it definitely doesn't hurt. And so we can see that negative 1 is the minimum of that graph and that 0, 3 is the maximum of that graph. So we're working on figuring out what is P and what is Q. So Q is going to be our amplitude, and it also is going to represent in case our graph was reflected in any way. So first of all, to figure out our amplitude, that's half our total distance. So that's from 3 to negative 1, so that's a total distance of 4. So half of that is going to be 2, so that's our Q. Now we do have to figure out if our graph was reflected. Typically our cosine graph starts at the top, ends at the top, and same idea here, starts at the top and it's going to end at the top, so there's no reflection, so it's going to be positive 2. And then we have to figure out how far our graph was shifted up, and basically we're just looking for the middle between 0, 3 and pi negative 1, the vertical middle. So halfway between 3 and negative 1, it's a distance of 4, so that's 2 from each side. So 2 up would give us 1, or 2 down would give us 1. So the middle is here at 1. And so that's our P, and that's all there is to it. There are tons and tons and tons of ways that they can ask you trig graphing questions. They do tend to more typically ask you to look at a graph and come up with things like P, Q, and R or A, B, C, and D, mostly because it's easier to grade and it leaves less room for error. It's also just less time consuming for you to do that than it is to actually draw a graph. But that's not to say that I've never seen them ask you to draw graphs. I've seen plenty of problems like that. It's just a little more tedious. You have to be careful, all of those things. So there's tons of ways. Look in your book, do some practice problems, and see me with questions.